So welcome back to Transcended Institute. In this tutorial, we are going to solve tutorial sheet 1 for Math 1100. Okay, so the first question here is saying, let U, that is the universal, be equal to 1, 2, 3 all the way to 10, and let set A be equal to 1, 3, 6, 8, 10. Let set B be equal to 2, 4, 6, and 8. And C be equal to 1, 4, 6, and 10. Find the following sets. Okay, so we have the first set that is saying we want to find A intersection B complement. Then here we also have a complement like that. So the first thing that we have to do is we have to bring the complement inside. So if the moment I bring the complement inside, what we have to understand is that when the complement comes inside, this sign is going to change from intersection to union. If it is union, it's going to change to intersection. So this case is going to be A complement union B complement complement. So there is a property that I want you guys to be familiar with. If you have B complement complement, so complement and complement will cancel each other, then you remain with just B. So initially here we are trying to find A complement union B. Okay, now it is very important for us first to list what we have. Quite okay, we have B, but we don't have A complement. So A complement, what are the elements that are not found in A? I'll go to my universal and cancel the things that are found in what? That are found in A. So A, we have got 1, so I'll eliminate 1 from here. Okay, I also have 3, I'll eliminate 3. I have 6, I will eliminate 6. I have 8, I will remove 8, and 10. So A complement, it is 2, the numbers which are remaining there, 2, 4, 5, okay, and 9. That is my A complement. So my A complement is 2, 4, 5, even 7, right? I've forgotten 7. I'm supposed to put 7 here. Okay, that is my A complement. Then what is my B? B we have already been given that it is 2, 4, 6, 8. Now we want just to rewrite all the numbers now which are found in A complement and B, but we have to write them together. So the number that appears twice, we write it once. For example, 2. So I'll just say it is 2, comma, next is 4, next is 5, 6, 7, 8, 9. So I can clearly see that I've now written all the numbers which are found in A complement and B. So the answer is 2, 4, 5, 6, 7, 8, 9. So this is the answer for the first part. Okay, using the same concept which I've given you guys, just try to do the second part. You know, the second part here, you can clearly see that it is telling you that A complement union B, then we have got a complement. So we can clearly see that if the complement comes inside, it will be A complement complement. This is going to change from union to intersection, then B complement, of which I know that A complement complement, it is just A. So you are finding A intersection B complement. Use the same concept, try to find the answer. Okay, so if you find the answer, you can send the answer, you can just type the answer in the comment section, or if at all you are a registered student, you'll be able to post the answer in the comment section on our website. Then I'll be able to check it out. Okay, so do part 2. I've left it from here. I want you guys to practice part 2. So I'll go direct to part 3. Okay, so part 3 is saying A intersection B, then union C. The first thing is we need first to find A intersection B. Okay, so what is A intersection B? Let's see the numbers that are found in both A and B. So A and B, one is not in B. I cancel it out. 3 is not in B, I remove it. 6 is there, I'm going to leave it. 8 is there, but 10 is not there. So A intersection B, it is only 6 and 8. Now we want to union this with C. C is 1, 4, 6 and 10. So then we can clearly see that A intersection B, then union C is going to be the number that appears twice, write it once. So I've got the first one is 1, the second one is 4, then 6, then 8, then 10. So this ends there. So 1, 4, 6, 8, 10 is my answer for this question. So you can clearly see that the moment I've solved this part, which is question 3, part 3, sorry, it's basically the same as part 4. So go ahead and try part 4. Okay, try to pause the video, solve part 4, and compare with the answer I'm going to find here. So let us first find A union B. So A union B, the numbers that are found in A, you write A and B, but the number that appears twice, write it once. So 1, we have again 2, so this is 1, I've written 1, I've written 2 to avoid mistakes. What other numbers? Then 3, 4, so I've written 3 and I've written 4. What else? Next is we don't have 5, so I'll go to 6. After 6 we have 8, so I've written 6 and 8, even here 6 and 8. The next one is 10. So then what is my C? Set C is 1, 4, 6, 10. So now we want to intersect now the numbers that are found in both this and this. That is going to be our answer. So A union B in the brackets intersection C, this should be equal to, let's see, 1 is found there, 2 no, 3 no, because we have 1, but 2 no, 3 no, so we have 4, we have also 4. So we have 4, we have 4, we have 6, we have 6 and 10. So this is the answer for part 4. So that is it for question 1. So the only question I want you guys to solve for me, it is this question, and I'll be waiting for the answer. So it's either you can just type the answer in the comment section, I'll be able to check it out, then I'll be able to reply. Okay, so that is it for question 1. Let us now look at how to simplify sets. Okay, so the question which I have is saying express each of the following in its simplest form. So it's something that is not complicated as long as you are going to follow simple principle and simple steps that I'm going to show you here. So let's begin with the first one. So the first one, we have a big bracket P complement union open brackets Q minus R, close the brackets, then a big bracket complement. So I want you guys to understand one thing. The moment if you have A minus B, this is the same as A intersection B complement. So if you have 7 minus 4, the answer is 3. So what does it mean? In 7, remove 4. So in A, remove B. That's why it's A intersection B complement. Okay. So then, let us now see how we can work out the first one. So the first one that we have is we have P complement union Q minus R complement. So if the complement comes inside, you know guys what happens. So it will be complement that is just P. This is going to change to intersection. Then I'll just say Q minus it is intersection, this one will have complement. Then this complement I'll just put it inside, it will be here. Okay, so I have P intersected with what? Now I'm going to bring this intersection inside, or the complement inside. It will be Q in complement, this one will change to union. R complement, complement is just R. Okay, now where I've reached here, I can't go any further from here because P is on its own, Q is on its own, R is on its own. So therefore this one ends there. It can't go anywhere. So another way on how you can know that okay, this is the final answer, just use a Venn diagram. So if at all you happen to use a Venn diagram, you have three sets. These three sets, put here P, Q, and put R. Inside the set, put numbers 1, 2, 3, 4, 5, 6, 7. Outside put 8. Not 7 but 8. So then if you list the numbers you have in P, you have 1, 2, 3, 4. In Q, now we are talking about Q complement. So I'll list Q complement. Q complement, in this case I have I remove Q, so I have what? 1, 4, 7, and 8. Then I also have R. So R, I have 3, 4, 5, 7. Okay, so now if at all I want to say Q, so I'll do this. Q, what is P? First P is 1, 2, 3, 4. Intersect it with the Q complement union R. So 1, 3, 4, 5, 7, 8. So the numbers that are found in both is just 1, 2, 3, 4. Okay, we have what? 1, no, there is not 2, so it is 1, 3, 4. That's all. So if you check 1, 2, 1, 3, 4, you check what you have here. I do not have 1, 3, 4. So if I don't have any set that is resembling that, then I'll conclude that that is my final answer. I can't go anywhere. Okay, but in the case where we had maybe 2, 1, 2, 3, 4, since 1, 2, 3, 4 it is P, I would have concluded that this is P. I hope you have gotten the concept there. So for that one we end there. That is the answer. P P intersection open brackets Q complement union R. So let us now go to part 2. Try to pause the video, then solve it. Okay, so the one that we have now is X union Y intersection X. The way it is here, direct, I can go direct because there is X outside, again another X has appeared inside. I'll go direct and use the Venn diagram. But here I can also use what we call absorption law. Absorption law, when there is X here, another X appears inside. This X is going to absorb everything inside here, and you end up with X. Okay, so from here just direct. If you don't believe, let me just, or if maybe you don't understand what is happening, I'll show you something. Let's have a Venn diagram. So I have X and Y. I'll put numbers 1, 2, 3, 4. So my X is 1, 2, Y is 2, 3. So what is X here? 1, 2. Okay, union, and then x intersection y intersection x is 2. Is 2 only. So if I get the union here, it is just 1 2. So 1 2 is x. That's why this one, the answer is x. You don't have to go anywhere. Direct, the answer is x. Let's go to part 3. So part 3, there's something that I want you to understand. We have to compress this. M intersection n in the brackets, then union, we have got M intersection n complement. So when you have anything in common here, okay, this thing which is in common has to be outside. For example, okay, I'll just do it from here. If at all I have got A intersection B intersect or union C, I want you to see, I can distribute this. This is the same as A intersection B, then union, then again A intersection C. So this, anything that is outside is going to go with this first, again next it will go with that other one. So this one is going to appear twice, then this one will appear in between. So that's how it is. So now the reverse of this, I can reverse this to that. That is what is happening here. So now here I'm reversing. I want to compress. The common one is M, so M will be here. Okay, then this guy is going to be here, which is the intersection. So here it will be N union N complement, of which I know that if at all I want to expand this, it's the same as M intersection N union, then M intersection N complement, which is this one. Okay, so now let's now continue from there. Let's try something. What is N union N complement? That should be the universal, but I want to show you where the universal is coming from. Use a Venn diagram to understand better. So let this be equal to M and let this be equal to N. Let's put numbers 1 2 3 4. Let's go ahead and list M. M is 1 2, N is 2 3, then N complement is 1. Then what else do we have? We are just removing everything in N, is 1 and 4. So I'll come here and say the universal, which is E, universal we call it E. Universal is everything 1 2 3 4, even the one which is outside here, that is the universal E. Then what is N? What is N union N complement? So I'm writing now 1 2 3 4. 1 2 3 4 is here, 1 2 3 4, that is the universal. So then what you have here, everything here is the universal. So M intersection the universal. So now what we are trying to do here is M is 1 comma 2, intersection the universal is 1 2 3 4. What will be the answer? The numbers that are found there, it is just 1 and 2. So it is 1 and 2. But again, if you look at the sets that you have here, what is 1 and 2? 1 and 2 is M. Therefore, the answer for this is just M. So anything intersected with the universal, it is that set you are intersecting it with the universal. As simple as that. Okay, so in case maybe you have anything like X union X complement, is the universal. Let me give you the overview. If you come across anything like A union A complement, the answer is universal. A intersected with A complement, the answer is empty set. Okay, so these are the general principles that you have to know, guys. They are also very important actually. Okay, so let's dive into part 4. So part 4, you can pause the video, try to solve, and then see what I'm going to find. So initially, this minus, we have a minus b. Now this minus, we know that minus goes with intersection. Okay, so this intersection is going to affect everything here. It will be here, but again, even this one here I have to change. So that will be a intersected with a intersected with b, complement, again complement. So this complement is because of this minus, this complement is because of this minus. Okay, now from here I can now distribute, I can now bring the complement inside. So it will be a complement union. Since I've brought complement inside the brackets, this changes. So it will be b complement complement. So b complement complement is the same as b complement complement, same as just b. Okay, so what else are we supposed to do? Let's now come up with the Venn diagram. But me from here I can find the answer. Okay, so from here, if at all you want, there are two ways here what you can do. Let me, before I even come to the universal, I can distribute this, I can expand it. So it will be a, remember what I said, it will be a intersected with a complement in the brackets, then this union, again a intersected with b. So remember, I gave you something. Recently I just told you to say a intersection a complement is empty set. You can't find, it's like this. You have got set a, there are nothing in common between set a and a complement, because a complement, you're removing what is in a. So there is nothing common in a and in a complement. So a intersection a complement is that. So union, then a intersected with b, like that. So you know that empty set, you don't have anything, you union it again, you find anything it with, you want to add with what is a intersection b, and you end up having just a intersection b. But again, if at all you're having challenges, even just from here using a Venn diagram, you'll be able to find the answer. But the best way is from here, just try to expand and see what we're going to have. I've expanded from there going there, then from here going there. Just try to understand those simple principles. It's very, very important. Okay, so let's go to 5. We go to part 5. So part 5 is saying a, we have got a big bracket, then again another bracket here, then complement union a minus b, then we have this. The first thing, let's first distribute this complement inside. So it will be a intersected with b. So complement is this one. Again, that complement has come inside this here. This one changes, intersected. Why is this not changing? Because I have only brought this complement to be here outside the bracket. So then this one, I know that a minus b is a intersected with b complement. I know that. So this complement comes here now. Okay, it will be here. Let's go. Complement and complement, these two will cancel out and we end up having a intersected with b, then intersected with, here we have a. That complement now becomes, it enters inside, it will be complement union b complement complement, which is just b. Okay, now I want you guys to understand again something there. Okay, let us try to understand something. Where we have reached here, I want us to see what is in common. Okay, let us see what is in common. So we have got a intersection b, again b, but here if we look at how things are, it will be impossible for me, unless if this guy and this guy, they were the same, then I would have concluded to say, let me just get b to be like this. If maybe it was maybe union, I would have said union, then I get this A and A complement. But in this case it's a bit different. So do you know the best thing that we can do? Let's use a Venn diagram. Okay, so a Venn diagram, we have got two things, A and B, set A and set B. So I'll have A and B. Okay, I'll have A and B. So then I'll have 1, 2, 3, 4. So let us go ahead and list set A. Set A is 1, 2. Set B is 2, 3. What else do we want? We have A complement. A complement, we remove A, so we have 3 and 4. So I'll first find what A intersection B is. So A intersection B is 2. Okay, I'll intersect it with it. Then I'll say A complement union B, it is 2, 3, 4. Okay, so if I intersect it, I'll end up having just 2. So I want you to understand one thing. I'll end up having 2. But what is 2? I don't have a set which is 2 here, but I already know that A intersection B is 2. Okay, so I can't leave this answer here to say this is my answer, because 2 is A intersection B. Therefore the answer for this is just A intersection B. That's the answer. Okay, that is very important for us to understand, guys. Very, very important. Okay, now try to do the last one. Try to pause the video and then try to solve it. Then you compare with the answer that I'm going to find. B complement intersected with A union B. Let's see. So the best thing is, let us first distribute this. So B complement intersected with A, union becomes here, then B complement again intersected with B. I told you guys to say A intersection A complement is empty set. So this is definitely B complement intersected with A union. These ones are in the brackets. This is empty set. So union with anything, so it's the same as you have A intersected with B complement. So that is my answer. So you can either write it to say B, because they started with B complement, you intersect it with A. But the best way is writing, just change it to A intersection B complement. That's the answer. So that is it for question 2. So let's now talk about disjoint sets. So the question which I have is, if A and B are disjoint subset of the universal set, simplify each of the following. So the first thing that I want you to understand is that a disjoint set is a type of a set that does not have an intersection. So if at all I have a Venn diagram, and this Venn diagram I have got A and B, but they are not meeting, A and B. Let's just assign numbers 1, 2, 3. Simple, right? So the first thing that I want us to do is, I'm going to list numbers. A is 1, B is 2. Then I need to list A complement again. A complement is 2 and 3. B complement is 1 and 3. That's all. So when it comes for disjoint set, just do what I've done. Then now start answering the question. Let's begin with the first question. So A intersected with B. The numbers that are found in both A and B from our set here, we don't have. So what do we say? It is an empty set. What of A union B? The numbers, we add the numbers, we put them together, the numbers which are in A and B. Okay? So what do we say? It is just 1 and 2. So if I look at 1 and 2, and then you realize to say 1 and 2 is not a set on its own if I check here. So it just ends here to say the answer for A union B is just A union B. Just like that. It can't be simplified more than that. So it's just A union B. Okay? But now let's look at these interesting ones. A complement intersected with B. A complement is this one and B. So the number that are found in A complement and B is just 2. Then you look at the sets you have here. What is 2? 2 only is B. Therefore, the answer for this A intersection B is just what? B. It has been simplified. Have you seen the logic there? If you just follow the logic which is happening. Let us try the next one. A minus B is the same as A intersected with B complement. So let's find the numbers that are found in A and intersected with B complement. So A is 1. In B complement I've got 1 and 3. The numbers that are found in A and B complement is just 1. But what is 1? From the sets that we have, 1 is just basically A. Then I'll say that A minus B, it will start from there. Then you say A intersected with B complement. Then the answer is just what? A. Done. Let's try the last one. A union B minus B. So A union B, okay, so this is A union B intersected with B complement. Let's first do this. What is A union B? A union B is a set that is, I'll write it here, but this is actually not part of the solution. I'm just showing you on how best you can find the answers. So these things I'm doing now using the numbers, I've just assigned the numbers randomly. So I'm going to put this number. A is 1, B is 2. So we want to intersect it with B complement. So B complement is 1 and 3. So the numbers that are found in this and this is basically what? It is 2. Sorry, it is 1. Then you look at the set that you have. 1 is just A. So the answer for that question is just A. As simple as that. So that is it for question 3.
Alright, so I believe for you to watch this far, you're enjoying this video. So just wanted to let you know that we've got a site where you can access the full solutions to your tutorial sheet, and all the tutorial sheets that are going to come out, you're going to find them on our site just here. Okay, so not only do you have the tutorial sheets, you also have access to all the topics that you are going to learn in the entire course for Math 1120, or if you are doing 1100 or any course. So we also have past papers. As you can see, these are a few past papers that we've added so far. You can even check last year's test 1 paper, Math 11 2024, and some other courses, the 1100 as well, you can see. So the link to this site has been added in the description. Okay, so yeah, pretty much if you want to ace your math exams, your assessments, this is actually the site for you. So since this is set theory, you have access to the entire set theory, for example. Yeah, and all the upcoming topics in mathematics, you have access to them, and all the new tutorials that will come out, we're going to answer them for you. Yeah, just thought I could share that. Yeah.
So I have now this question, that is question 4, saying display each of the following intervals on the little line, that is number line. So one thing about set interval notation is that when we're using this, meaning it is not included. If I use this, then it is included. That number is included. So for example, the first number, if I get my number line, okay, if I get my number line, so this number line, what I'm going to do, I'm going to put negative infinity to positive infinity. Then what I'm going to do is, in this number line we have been told that we have got negative 1 and 1. So it is, they are using crossed one, so it is included, this one is included. Then I just join this line. That is what we have, guys. So you can try to do the second one. Okay, so the same number line, if I do the second one, we have negative 4 and 1. So negative 4, it is open, it is not included, but at 1 it is included, so it will be closed. Then up, just like that, done. Then the next one is negative 4 and 1, both are not included, so this will be just open, even here open, then you put the line like that. The next one is negative 1 to positive infinity. So this number line, negative 1 is here. Let me put negative 1 here. So from negative 1 not included is open all the way to positive infinity. So that positive infinity, you just put an arrow. So you only use arrow when it's going to positive infinity. Okay, try the second one, or this one, then we see. Oh sorry, that one I've already solved, right? This one, from 0, let's put 0 here all the way to negative infinity. From there it goes there, then I put the arrows. That's all. So that is it for question 4. So let's go ahead and talk about question 5. That is saying, where possible, rewrite each of the following interval in set builder notation. So set builder notation, guys, I think you are familiar with set builder notation. So what does it mean when you say open negative 10 all the way to 10 included? Meaning that if at all I'm using x, so x, in that case, the number that we are looking for, the number that should not start from negative 10. So x is greater than negative 10 but less than or equal to 10. So 10 is not, negative 10 is not included. So you do it like this. So set A is this. So you say x is such that, so initially we are starting, x should be greater than negative 10. We are not starting from 10, but should be greater than 10, but x again should be less than or equal to 10. Why am I using less than or equal to? Because it is crossed, it is included. Okay, so now how do we rewrite, how do we combine this? I want you to know something. How do we combine this when I tell you to say x is greater than negative 10, but again x is less than or equal to 10? So how do you combine, like putting them in the set builder notation? So now you start with the number that is the least number. In this case, I'm going to say negative 10 is less than x, then x is less than or equal to negative 10. This one, if I flip it, you can clearly see that the open part is with x. Even here the open part is with x. So then here I'm going to say negative 10 is less than x. Again, x should be less than or equal to 10. But again, what else should we know? Okay, but x should be a member of what? X should be a member of all real numbers, like that. So I've put this in set builder notation. So initially what is happening here is that the number that if you have got two numbers, just put in the first thing. Okay, let me just do it the second one. I'll show you something. Okay, so the first thing, we are done with this question. Let me now go to part B. If you didn't understand part A, it will be easy for you to understand part B. So write this B, it will be x is such that just leave a space, and then you look at this, the first one here, it is closed, so it is just less than or equal to. Okay, write it like that. Then put x here again, put it, they are supposed to be like that, so this is also included. So now you start now following the number that you have. The number that you have here, this 4, will be first here. The number that you have on the right side, it will be here. Then comma, x is a member of all real numbers. I hope this is not hard. Okay, it's not hard. So if I do part C, try to do part C. So part C, I'll do the same. Since I've got two numbers there, I'll say C, I'll say C I'll say C, I'll write x is such that, leave a space. Now the first part here which we have, it is open. You just check here, this is open, so you just write less than, then put x. So the next one, this is closed, put now less than or equal to. Then the number that is on the left side, put it here, -1, then put 5 here, then put comma, x should be a member of all real numbers. Simple, right? Yeah. So then let's try to do the last one. So the last one that we have is D. We have infinity, and then this means that it is starting from x should be greater than or equal to 0. So it is the numbers from 0 all the way to positive infinity. So this one is just direct. X is such that x is greater than or equal to 0, then x is a member of all real numbers. That's the answer. So set beta notation is something that is not complicated. Again, it is possible you can come from set beta notation to set interval notation. Okay, so that is it for question 5. So let us go ahead and also solve question 6, which is saying let R be the universal set and A be equal to open -1 to 6, then 6 is included, B is equal to 4 or 0 to 4, but they're both not included, and C is they're saying x is such that x is greater than or equal to 4, then x is a member of all real numbers. So we're trying to illustrate this into on the number line. So let's analyze C. So C is saying that x is greater than or equal to 4. It means that starting from 4 all the way to positive infinity. But remember, I mentioned last time to say when we're talking about the infinity, we don't include. Okay, so in this case what we're going to have is this is set C now. So now A minus C is basically the same as A intersected with C, then put a complement. So now the universal set that we have, if they have not mentioned anything about the universal set, just know that the universal set is from negative infinity to positive infinity. Okay, so I'm going to have my universal set here. So I'll have my universal set negative infinity to positive infinity. So I'm going to put 0 in between to demarcate, to separate the positive and the negative. So let's begin. The first one we are talking about A. So what is A? A is from -1 all the way to 6. So where should we put 6? Let's put 6 here. Let's put 6 here. And then, so meaning that what I have now is A -1 is not included, there is open. So I'll put an open like that. But 6 is included. I'm going to put it like this. So then we do this. That is my what? That is my set A. Now let's go to B complement. Initially B is from 0 all the way to 4. I'll put 4 here. So this is A. Sorry, this is C. Oh, in fact that is B. C is this one, guys. Sorry. So 4 all the way to positive infinity. 4 is included. So from here all the way to that side, that is C. But we want C complement. So C complement is starting from this point open, because 4 is included, meaning that the complement should not be included. 4 should not be included. Starting from this point, going this side. Okay. So that is my C complement. Now we want the part where these C complement and A, they are meeting, they are intersecting. So initially I'm not interested in this line. Okay, I'm not interested in that line. I'm only interested in C complement. So it is this point, starting from here, going there. So you look at the last part, it is open. Even this part is open. Therefore the final answer is going to be -1 not included all the way to 4 not included. So this becomes my answer. Now try to do the same to solve part B. Sorry, part 2, not B, part 2. So try to pause the video, solve the question, and then compare with the answer that I'm going to find. So let's see. So the answer that I'm going to find here, I'll put my number line. Okay, I'll put my number line here. Again, from negative infinity to positive infinity, I'll put 0 in between. So we are dealing with B complement intersected with C, but outside there's complement. If the complement comes inside, so it's going to be complement, that is going to be just B. Then intersection will change to union. Then it will be C complement. So we're trying to find B union C complement. So let's first look at B. B is 0 to 4. So I'll put 4 here. So from both that are not included, this is my B. Okay. But remember we had C complement for the first question. C complement, since C is from 4, C is from 4 to positive infinity. So meaning that C complement is starting from 4 but not included, because 4 is included in C. So starting from here, not included, all the way to negative infinity. So that is C complement. Now union, we are just writing everything that we have. Okay, so this is my union, meaning that the answer for this question is starting from, okay, so the answer for this question meaning is what? Starting from negative infinity all the way to 0, but 0 should not be included, because both this and this, they are not included. Now in a case where 1 was included, I would have followed the one which is included. So, but in this case both are not included, so I'm not going to say it is included. I hope it's making sense. Okay, so then let us go ahead and also do part 3. So part 3 is saying C minus A, okay, intersected with B. So then I know that this is the same as C intersected with A complement, then intersected with B, like that. Then I'll do this. So I'll do the same. I put negative infinity, I put positive infinity. So 0 should be in between to separate those two. So let's first go ahead and do C. So C is from 4. I'll put 4 here. 4 included all the way to positive infinity. That is C. What is B? Before I come to A complement, but if I want, I'll come to A complement. A is from -1 all the way to 6. That is A. But the complement, so from here not included all the way to this part included, that is my A. But I'm not interested in this line. I'm interested in A complement. So then I'll say A complement should start from here. If this is not included, then the next one, the complement should be included. That is A complement. Another A complement will start from here, but this is included, so it's not going to be included going there. That is also again A complement. So I am not interested in A, so I'll remove it. Okay, I'm not interested in A, I'll remove it. So what I'm going to do to make things easier, I'm going to shift this a bit to come here, also this just to come down here. Okay, now let's go and represent what? C. So what is C? C, or C, I've already done that. Now we are meaning with B. So B is from 0 to 4. From 0 not included all the way to 4 not included. That is my B. Okay, that is my B. So what we are trying to do now is we want to find the points where C, A complement, and B complement, where they meet, where all the three lines meet. Okay, so I can clearly see that B is not intersecting with anything. So B is not intersecting with anything, then that gives me an idea to say that should be an empty set. Okay, that should be an empty set because it's not giving me anything here. So since I need a point where C, A complement, and B where they meet, for example, if it was A complement intersection C, I would have gotten this part here. But in this case, I'm trying to get where all the three lines meet, and I can clearly see that B is just alone, it's not meeting with anything. Therefore, the answer for this part is what? Empty set. So after right now, how do you write the answer? The way I've done it here, and then you have to show these lines, everything what I've done, and show that they are not meeting. Therefore, the answer for this one, it is empty set. Okay, I think you can do A complement only. Now we're trying to do what A complement is. So I'm not going to get rid of the number line, I will just get rid of this. Okay, so A complement, that is part 4. So A only is -1 all the way to 6. -1 to 6. So this is A. -1 not included, but 6 is included. That is A. Meaning that the complement, this should be included all the way to -infinity. That is A complement. Again, from here, since this is included, the complement is not going to be included. That is A complement. So you remove now this. So this is my A complement. So therefore, A complement is starting from -infinity not included all the way to -1 included union. I am jumping this part. We jump, then we go to open because this is just open, then 6 all the way to positive infinity. So I found the answer. I've also displayed the answer on the number line. Okay, so let's do the last one. So the best way you can do is to pause the video, try to solve the question, then compare with the answers that I am finding here. Okay, if at all you have seen that maybe I have messed up or I've made any mistake, you are welcome, guys. You can either type it in the comment section, then I'll be able to see and I'll be able to go back to what I've solved, then I'll try to correct. Okay, so let's do the last one, which is so the last one is saying we are finding A intersection B but outside is complement. So if the complement comes inside, we clearly know that this is going to be A complement union B complement. This is De Morgan's law now. So when you bring the complement inside, intersection changes to union. If you have got union, changes to intersection. So A complement, we are from doing A complement. A complement started from here. A negative 1 is not included, so the complement will be included. A complement. Then 6 is included here. So this part 6 should not be included all the way to that point. That is again A complement. What is B complement? B is from 0 to both not included, meaning that the complement is going to be included. B complement again all the way to 4. 4 is not included, meaning from there going there. So when we're talking about the union, we are just writing everything that we have. From there, then we jump again this part. So the answer becomes from negative infinity all the way to 0, not included. Sorry, it is included because this guy here, it is crossed. So 0 is included, union. Okay, then union what? Again, from 4 is included all the way to positive infinity, not included. So that's my answer. I've displayed it on the number line and giving again the answer. So that is it for question 6. I hope you guys have managed to follow through. Now try to explore different questions and try to solve under set interpretation. Okay, that is it for question 6. Now let us go to question 7. So question 7 is basically the same as question 6, but the only difference is the universal set, okay, and also set C, but the rest are the same. Even the questions are the same. Okay, so now this is saying for set C is telling us that x is greater than or equal to what? Negative 4. So it's negative 4 less than or equal to x. So if I flip it, it will be like this. Okay, so then I can clearly see that this is starting from negative 4 all the way to positive infinity, but negative 4 is included. Then the next thing that I have to do is to solve part 1. A minus C is the same as A intersection C complement. Let's go ahead and look at our universal set. Okay, so then our universal set, we have been told that it is 10, negative 5, open, and 10, open. So I'll put negative 5 here and then 10 here. I'm going to put 0 in between just to demarcate, to separate the negative and the positive. So what is A? A is from negative 1 all the way to 6. So that is A. Both negative 1 is not included, but 6 is included. So this is my A. Next, what do we have? We have C. So C, but C complement. Now C is negative 4 all the way to positive infinity. So meaning that C complement, sorry, so this cannot end there. Now just a minute, let me just make a few corrections on C. So C is saying if we follow the universal is from negative 5 all the way to 10. Both are not included. Okay, so if both are not included, then we should take note that even this set C is not going to reach to infinity, but we follow the universal. So the universal ends at 10, so it will be 10. Then you follow what you have there. It is open, so even here it will be open. That is a few corrections that I have to make. And then another thing that we have to take note here, guys, is we want to see what C, we want to have C complement. C is from negative 4 all the way to 10. Okay, this is included, but the other one is not included. So what do we do now? What I'm going to do is I'm going to to say C is from negative 4 to 10. So the complement, meaning since it's negative 4 is included, that should not be included. It has to come there. Again, you follow that. That is C complement. So we want the part where they are meeting, the intersection. Okay? The part where A and C, they are intersecting. That's the part that we are looking for. Okay? So we can clearly see that they don't meet anywhere. So therefore the answer is empty set. Okay? Try B, and then let me go direct to C. I think D you can, part 2 you can do it. So try part 2, send me the answer, I'll be able to check it out. So we clearly know that this is going to be again the universal. We already know the universal is from negative 5 to 10. So that is the universal U. I'll put 0 to separate the negative and the positive. What else am I supposed to do? The next thing that I'm going to do, C minus A is the same as C intersection A complement, then intersect it with B. So let's begin with A complement. So A is negative 1 all the way to 6, but 6, we are now getting the complement. So since negative 1 is not included, the complement will be included. It will go there. So I follow the universal there. Here it is included, 6 is included, so the complement is not going to be included. That is A complement and A complement. Again, what I have done here, what I have written here, I have answered this question. So before I even finish solving this, let me first solve that one. So A complement is going to be negative 5 all the way, negative 5 not included all the way to 1, included, union 6 all the way to 10 not included. That's A complement. So I'm done with this. So before I even go further, let me now go back to part 3, sorry. Okay, so now I want to also to look at C. What is set C? Negative 4. Okay, negative 4 all the way to 10, negative 4 included all the way to 10 not included, because the last part here should be open. That is C. What of B? So set B is from 0 to 4. I'll put 4 here. So from 0 not included to 4. That is B. So we are trying to look at the part where all the 3 lines are meeting. Okay, we are trying to look at the part where all the 3 lines are meeting. Where is that part? Okay, so let's see. Do we have any part where the 3 of them are meeting? No, I do not have that part. So again, this one we are going to say it is an empty set again. So if I go to now the third one, I'm going to get a lot of empty set here, the way I see it. Even this one, let's see. Which one is that? Okay, where are we? So the first, I'm here. The second. Now since I've solved this one, okay, let me solve the number 5. I'll solve number 5 from the number line that I have. I'm looking at, if I bring that inside, is A in complement intersection B complement. So what is A complement? A complement, we said, starting from negative 1, because A is negative 1 not included, so complement will be included. It goes there, A complement. What else? Again, it goes to 6. 6 was included, so the complement is not going to be included. Again, that is A complement. Let's look at B. B is from 4, 0 to 4, both not included, meaning that the complement should be included. That is B complement. If in this side 4 included, going this side, B complement. So intersection, we were looking at the part where they are meeting, not so. So it was actually union. Let's see. Oh, it was intersection. So when I bring the intersection inside, it's supposed to be union. A complement union B complement. So that should be this part here. Reaching there, then we jump again this part. So the answer should be from -5 all the way to 0, 0 included, union, then 4 because this last part is included, all the way to 10 not included. That is the answer. Okay, so I believe what I have done here, you can do the same for part 5, for part 6, sorry. So try to do part 6 and then show me the answer that you are going to find. You just bring the complement inside, it will be like this. Okay, now using, in fact here, why should we waste time using this number line which I have? I can still find the other one. Let me even show you how we can find it. So we are finding A complement intersection B complement. So it is this part from this number line. I reach here, then I jump again here. So it will be from 5, -5 all the way to -1. -1 is included union. Then now this one, it is open. So open 6 all the way to 10, that. Okay, yeah. So that is it for question 7.
Alright, so I believe for you to watch this far, you're enjoying this video. So just wanted to let you know that we've got a site where you can access the full solutions to your tutorial sheet, and all the tutorials that are going to come out, you're going to find them on our site just here. Okay, so not only do you have the tutorial sheets, you also have access to all the topics that you are going to learn in the entire course for Math 1120, or if you are doing 1100 or any course. So we also have past papers, as you can see. These are a few past papers that we've added so far. You can even check the last year's test 1 paper, Math 11 2024, and some other courses, the 1100 as well, you can see. So the link to this site has been added in the description. Okay, so yeah, pretty much if you want to ace your math exams, your assessments, this is actually the site for you. So since this is set theory, you have access to the entire set theory, for example. Yeah, and all the upcoming topics in mathematics, you have access to them, and all the new tutorials that will come out, we are going to answer them for you. Yeah, just thought I could share that.